Today, we are digging into a really hopeful idea, one that's been gaining a lot of ground lately. And that's the theory that changing how we farm could be a massive weapon in the fight against climate change. I mean, it's a powerful question, isn't it? The idea here is that our agricultural soils, which, have often been depleted of carbon, could be turned into a giant carbon sink. We're talking about literally pulling CO2 out of the air and storing it right there in the earth. But how would that even work? Well, meet the hero of this story, conservation agriculture, or CA for short. Now, the key practice we're going to focus on is called no-till, and it's pretty much exactly what it sounds like. Farmers plant seeds directly into the soil without churning it all up with plows. This, plus keeping the soil covered and rotating crops, is supposed to build healthier, more carbon-rich soil. Okay, so let's dive into this, because when scientists first started modeling the potential here, the numbers they came back with were, well, they were huge. I mean, we're talking game-changingly big. This right here was the headline number from a major analysis back in 2019. It claimed that conservation agriculture could sequester 143 teragrams. That's 143 million metric tons of carbon every single year. And that's just across the African continent alone. Just to put that into perspective for you, if these numbers were accurate, this wouldn't be some small, tiny improvement. This would be a major, major tool for mitigating global warming. It would give policymakers a powerful new strategy to invest in. But, as with many things that seem just a little too good to be true, other scientists started digging into the data. And they started asking some pretty tough questions. And what they found, well, it changes the story quite a bit. And this was the crucial question. Are these no-till practices actually creating a net increase in soil carbon, really pulling it from the atmosphere? Or are we just, rearranging the carbon that was already there to begin with?
So, when researchers first looked at soil samples, the results seemed pretty clear. As you can see in this chart, in the top layer of soil, say the first 20 centimeters or so, no-till fields consistently showed more organic carbon than the old-school tilled fields. It looked like a clear win.
Now, this is where it gets really interesting. Look what happened when scientists decided to dig deeper. When they analyzed the full soil profile, going down to 40 centimeters and even beyond, that advantage completely vanished. The total amount of carbon was often no different at all. See, the carbon wasn't new. Conventional plowing had simply mixed it deeper into the soil, while no-till was just concentrating it near the surface.
Think of it like this. Plowing is like mixing all the ingredients in a big bowl, distributing them throughout. No-till is more like just adding ingredients to the top without ever stirring. So if you only look at the top, you get a really misleading picture of how much is actually in the bowl. It wasn't a true carbon deposit, it was more like an artifact of where we were measuring. And this table really just drives the point home. It compares that initial optimistic claim for tropical Africa with what a later, more rigorous review found. And not only was the observed rate lower on average, but look at that variability. That plus or minus 1.06 tells you the results were all over the place. A lot of sites showed little to no carbon gain whatsoever. The critics also pointed out that those massive potential figures, they were based on some pretty shaky assumptions. I mean, they assumed 100% of farmers would adopt these practices immediately, which is just not realistic. They also kind of ignored that sandy soils hold way less carbon than clay soils, and they even included newly cleared farmland, which actually loses massive amounts of carbon at first, no matter how you farm it.
But the complications don't even stop there. Because when we talk about climate, it's not just about carbon dioxide, right? We have to look at the whole picture, all the greenhouse gases. And this is the trade-off. It turns out some studies show that no-till practices, by creating denser, less aerated soil, can actually increase emissions of nitrous oxide, N2O, and N2O is a greenhouse gas that's nearly 300 times more potent than CO2. So even a small increase in N2O can completely wipe out any climate benefit from the carbon you might have stored. So the crucial point is this. Does all this mean conservation agriculture is useless? No, absolutely not. It just means we might have been focusing on the wrong benefit. We kind of need to reframe its primary role. So let's be super clear on the difference. Mitigation, that's about stopping climate change at the source, cutting emissions. Adaptation is about surviving the changes that are already locked in. The scientific consensus is now shifting to view conservation agriculture as a powerhouse for adaptation, not large-scale mitigation. And the proven benefits here are immense. It drastically reduces soil erosion, it improves soil health, and it allows the ground to soak up and hold more water. This makes farms far more resilient to the droughts and extreme weather that climate change is bringing. And for farmers, it can also mean saving money on fuel and labor. These are real, tangible, and absolutely vital benefits. Now, you might be thinking, okay, so it helps. What's the big deal? But getting this distinction right, the one between adaptation and mitigation, is absolutely critical for how we tackle the climate crisis. This quote from the scientists who challenged those early numbers, it really gets to the heart of it. The danger of overhyping one potential solution is that it creates this false sense of security. It kind of lets us imagine an easy way out that distracts from the main, non-negotiable task, drastically cutting our emissions from burning fossil fuels. So, what's the takeaway here? Well, conservation agriculture is a fantastic, essential tool. It helps us build a more sustainable and resilient food system that can better withstand the shocks of a changing climate. But it is not a silver bullet. It's an important piece of the puzzle, for sure, but it can't replace the urgent primary work of decarbonizing our entire global economy. And that really leaves us with a final thought. In our search for solutions to the climate crisis, we desperately need hope and innovation. Of course we do, but we also need rigorous, honest science. The real challenge, then, is holding both of those at the same time, embracing promising ideas while also having the courage to follow the data, even when it tells us a much more complicated story.